Hello, hello, testing. All right, I think we're on.
Hello.
Hey everybody, thank you for joining. We're here today and we're going to talk a little bit about some green innovation and technologies that's in the form of passive house construction. And we have Ken Levenson, who's the executive director of the Passive House Network, Oleg Slivinsky, who owns Green Home, which is a passive house consultant firm, and Vito Vamico from Planet Construction, who's built a few passive houses, to talk about their experiences and how we can get done and what this can help us do for our clients and the world. Ken, I'll let you take it away.
Great. Thank you, Neil. So I'm going to do a quick introduction to Passive House to kind of set up our conversation up here and hopefully spur some questions. So first off, how many people have heard of Passive House as a design methodology? We're all one. Great. You've heard of it and learned a little bit about it previously. Wonderful. Wonderful. So we'll do a quick introduction to Passive House because I think it's really exciting. I'm an architect by background. I practiced for a couple of decades, got into it, and spend my time now really about training and introducing it to people and helping spread the word. My organization is the Passive House Network. We're a 501c3 nonprofit doing training. We're based in New York City, but we're nationally focused. So if you're working anywhere in the United States, we can help you. And as I said, I'm an architect. My start with Passive House, I managed to have a client do a Passive House retrofit of a pre-Civil War townhouse in Brooklyn Heights. So this is a building that was well over 100 years old and be able to bring it up to this standard that we're calling Passive House. Historic building, so anything's really possible. Now, the boring aspect of Passive House is that it's an energy efficiency standard. Like really, not that interesting in and of itself, but what's really cool is that it has the designers and the builders working with energy. So there's heating demand and cooling demand and things that you target, but the energy efficiency is used as a design tool that helps drive comfort and health and resilience and security. And so you find that a passive house, if you step into one, is going to be the most comfortable building. It's going to have the best indoor air quality. The noise of the city is going to go away. You can sit by the windows on a cold winter day and not have any discomfort and not have heat at the windows. It's just comfortable. And the benefits are quite a few. So depending on what you care about, it can really help you deliver it. Resilience and safety when the power goes out, that you can shelter in place. And it's affordable. As energy costs go up, because it's so energy efficient, it's much more affordable to maintain. In terms of owning the building, it's more durable construction. There's reduced maintenance, and you have this perpetual energy savings. Generally, we see resulting as a high-quality asset where the occupants are very happy to be there. We have lower vacancy and a lower risk investment at the end of the day. So Passive House is a methodology as well, and what it does is it focuses us on the real drivers of what makes performance. So we design buildings all the time and do them, but we're not really sure about the end result. Consequently, mechanical engineers oversize the heating and cooling systems just to make sure that you're covered. You're going to be using way more energy than you necessarily need to be comfortable at the end of the day. And Passive House, by focusing on these 5 drivers, very simply, climate-specific insulation levels. So if you're in a cold climate, you have a good parka on. If you're in an easier climate, a lighter parka. That insulation, we want to have thermal bridge-free connections. It's number 2. Number 3 is air tightness. Number 4, high-performance windows and doors with solar protection. These 4 things are all about the architecture. It's all about the design of the building, of the enclosure. And with those, we complement it with high efficiency heat recovery ventilation to make sure we have really good indoor air quality, no matter what's going on outside. And just to drive this point home, you know, having a good thermal enclosure means if it's hot outside and we want to keep the inside cool, it's going to help us, like a cooler, like an ice cooler. And vice versa, keeping ourselves warm in the winter. In typical buildings, the insulation that we do have is undermined by thermal bridges. It's all kinds of structural elements that makes our buildings effectively radiators to the world. And so you could see, like these typical buildings on the left, they're not very efficient. They're spending a lot of money heating the environment outside the building. The building is not holding that energy. On the right-hand side, we see a typical like coffee pot on the left, which isn't well insulated. It's again, we're heating to just heat and heat and heat, as opposed to a thermos that's holding the heat well. So this is what we want to make sure that our buildings perform. The windows are extensions of this. Oh, I think I went back. Airtightness is something that folks aren't necessarily so familiar with, but we want to keep the air pollution that's outside, outside. We want to control the air that's in the building. So if you're near a highway, industrial area, it could be wildfire smoke, it could be allergens. We want to have control of that. Now, we can open the windows and have fresh air come through, but it is up to the occupant as to whether they need to open the windows or not. Controlling air infiltration helps the quality and durability of the building. And the windows are extensions of this insulation and airtightness. And so you see on the left a typical building where the windows and the frames are, again, these areas where heat is being lost, energy is being lost, and it makes you uncomfortable. You feel the coldness coming off the windows, right, on those days. And on the right, the windows are much closer in temperature to the surfaces around it. Complementing the windows, we have exterior shading to control overheating. And then the ventilation. So the ventilation is fresh air coming in continuously. The stale air is being exhausted continuously. It's filtered fresh air. And we're recovering the heat from the exhaust air, so we're not wasting energy. So with these 5 things, we are calculating the energy balance of the building, and we can reduce our heating demand up to 90%, our overall energy demand up to 75%, and radically change the energy profile of the building while guaranteeing these qualities of comfort and health and security. So it means, like that house in Brooklyn Heights that I did for the clients, all the neighbors had 12 to 15 tons of air conditioning for the similar houses next door. They're 5-story houses. We installed 3 tons of air conditioning, radically different. And the house sails through the heat of the summer and the cold winters just fine. It's easier to go all electric and many other benefits with that, freeing up space. It is high quality construction. It costs a little bit more than typical construction, but we see the budgets pushing towards parity. So depending on what the clients are looking for, if they want super comfortable, super good indoor air quality, lower energy bills, it may be worth spending a few dollars more up front to have these qualities and then have it pay for itself. The designs can be any type. It could be modern, it could be traditional. We see single-family homes from Boston to Santa Fe, New Mexico. We see luxury housing, we see affordable housing. A lot of housing in New York City, multifamily is going to be passive house. We see hotels, we see factories in different climates. On the left is the Hotel Marcel, which is on 95 in New Haven, if you drive up 95. schools, a university on the left, and on the right is the elementary and high school, public high school on Flatbush Avenue in Brooklyn. So these methodologies and approach to building and optimizing the building can be applied anywhere in the world. And certainly we see wide application in the tri-state area. And we see it being used successfully as a design tool and bringing together the designers, the owners, and the builders to really produce a high quality product that's calculated and predictable so that you can count on it, the end result, at the end of the day. So that's my quick intro.
All right, thank you.
And from there we can have a discussion. Thank
All right.
you.
Sounds good. Thank you, Ken. So I know that everyone sort of gets introduced to this at some point, or at least in the spheres that I'm in. So Ken, why don't you just let us know a little bit about, when you first started to look into this. I know you've been an architect for 30 years now, something more?
15 years.
I'm sorry?
15 years?
Yep, okay.
Yeah.
So when did you first get introduced to it? What were your initial reactions, and kind of why do you think it's important?
Yeah, so for me, as practicing as an architect in New York, I was concerned about sustainability and bringing a more holistic approach to my design and what I was doing. And I was very frustrated in not knowing what the results actually were and what I was getting back from it. And I came just searching on the internet, came across Passive House, and it was this thing that was a methodology. It did not dictate design. You could design how you would like, but it gave you this kit of tools to actually bring predictability and to give you results where you could actually determine what you were achieving. And this was a revelation to me at the time, and I was able to take training pretty early on and really able to very luckily convince some early clients to go for it. And it was interesting. It wasn't like I was saying, would you like to do a passive house? They'll look at me funny. Why would I want to do a passive house? What's a passive house? But if you ask my clients, do you want to have really good indoor air quality for your children? Yes, that totally makes sense. Do you want it to be really comfortable? No drafts, no temperature differentials, no convective loop currents. And, yes, I would like to have thermal comfort. Would you like to have low energy bills? It's all very attractive. And it's like, okay, well, we're going to do this methodology and we can hit all these marks for you. And so with that, it was like a couple of projects I was able to do very, very luckily, and then kind of set out to help grow it and start some associations to help spread the word, do some training, started a company to help enable people to work with some of the specialized products that are dealing with Passive House and help grow the market.
All right, very good. Oleg, what about you? I know you recently got introduced to it, and your background might be a little different. I guess, why don't you speak a little bit about that?
Okay. Hi, everybody. Welcome. I guess by education I was electrical engineer, but after 20 years in the field, I get a little dissatisfied. And I was always kind of interested about the construction. It drove my wife crazy because I could actually spend hours watching how they actually pour concrete in a construction site. And about 15 years ago, I just heard about Passive House. There is a community in Brooklyn, in the Prospect Park area, where it's actually all Passive House started up. There was a lot of meetings there, so I went, and it was introduced to the 5 principles of Passive House, and it made such a kind of a perfect sense to me. That's how you would design a building. Most of the focus was on energy, but with energy came the comfort, as Ken was saying it. And it's just like none of us, as far as I can tell, like experience like living in the passive house, experience that kind of a comfort, being totally comfortable inside with no drafts, no air conditioning or heating system really blowing on you. It's either you hot or cold. It was just sitting next to a large window would actually be comfortable and just watching outside. The quietness of the passive house, living in Brooklyn with all the sirens and the traffic, you just close the door window and you just in a total silence. That's really kind of unheard of in the present, even in the present construction. What else can I say? I like it so much, I quit my job and I passed the passive house exam and opened my own business. So I'm doing a passive house consultant. So in a period of 15 years or so, I met a lot of clients, and it's just like, it's really interesting to see what people really like. And most of the time, people are going for the really comfortable living and really quiet living. And that's what the passive house delivers. The interesting aspect, since it's all based on science and real-time simulation, it's actually very predictable in terms of outcome. If you follow particular, all the steps in the right direction, then your building will be comfortable. And it's been proven, it's in Europe, and it's been proven here in the United States, all over, in all different climates. It's all just comfortable living. So that's pretty much it.
All right, thank you. So Vito, I know, and you're coming from the construction end, because as a contractor, when was your first introduction to this, and I guess what have you found for building?
Well, I think passive house is the future, and I've done a couple of them already, and I'm glad to know these guys, to work with them. That's it.
Thank you. So I guess, and for me, I encountered a lunch and learn at some point, maybe it was like 10 years ago that Ken gave on this, and I had finished LEED certification a few years before, and I think what I found about it was that the thing that bothered me about LEED and other green certifications is that it's sort of like a bunch of check marks. And you check the boxes off and you get your certification, and there's really no connection to anything else. And I think Passive House is really about building it well and having a sort of a well-built structure. So it really focuses on, building properly and following those methods, and it's really a lot less about, using a material that was recycled and more about, getting the actual performance of your building better and having the people that are in there comfortable. So I think that's what really appeals to me, because we try to, focus our work on, client and customer satisfaction, and this is really the core of what building like this does. So I guess, all of this sort of sounds great, but I guess the question that everyone sort of has is, what's the premium? Ken, do you want to speak to that a little bit, or who wants to go first on that?
Do you want to start, or what do you see on your project?
The premium, it depends on the size of a project. Usually the single family buildings, since about 3,000 square feet, it's going to be between 5 and 6% premium. And once the project gets bigger, the premium becomes really negligible. It costs the same as a regular construction.
Yeah. And so to add on that, I think one of the things that we see with the Passive House projects is it's really about investment and experience. So those first projects are the toughest ones, right? Where you're learning, because you're trying to optimize all these different components of the building that are delivering the performance, the efficiency, the quietness, the comfort. And some windows can cost more and some can cost less, and a little more insulation or a little less insulation. And depending on how you bring together the parts, you can achieve really high performance results, and including the program of the building. And as teams have more experience, as designers and consultants have more experience, we see that cost premium coming down as well. I think, yeah, I would leave it at that.
Well, I think I'd want Vito to maybe speak to that also, considering he's probably tied more closely to the cost, but how was that affected on the first couple of builds you did, and what was that adjustment like?
I think it's a little bit more to build it as far as insulation is concerned, tightness of air.
Do you find that you
Yes,
have
but-
to spend more time with the trades?
Yes, definitely. A lot more time with the trades, make sure everything is correct, make sure there's no penetration that you haven't sealed. So it's a little more complicated.
And is that, sorry, go ahead.
It's actually 14 years since the passive house kind of landed in U.S. shore. And since then, there is so much product which can be used. And I'm not talking about windows, I'm talking about all the necessary insulation, membranes, and everything in between. Mechanical equipment, it gets to be so readily available. So it's really easy to build passive house because everything here is available. It's just a matter of actually putting it all together for a particular house.
All right, thank you. And I guess, does that vary based on project type? How different is building when you're coming to, let's say, a single-family home versus a multifamily building? What are the different challenges, and how do you, I guess, reconcile those with construction?
Yeah, I mean, I would say that the bigger the building, the easier it is. So you have issues of scale that make it more easier to hit you more easily hit the targets in terms of performance, and you have the issues of scale just in terms of cost effectiveness and what you're doing. So single family, you need to work a little bit harder to make sure you've got all the cost effectiveness locked in, but it's certainly doable. One thing I wanted to note was that whether it's a single family home or multifamily building, what you want to do is start using passive house as a methodology and a guide from the beginning of the programming when you're starting the design and thinking your way through the project. You don't want to have a project that's fully designed and ready to go out to bid and say, oh, I've heard of passive house, let's convert this into a passive house. Because that will be very painful and be the most inefficient way to kind of hit the targets. So bringing passive house along in the design process is critical to being successful.
So I guess, what are some of the challenges and ways that you might have to design differently? And I guess, can you speak to some of those as to sort of, what to be aware of from early on and that type of thing?
I mean, I'll just start to say that it does force you to think holistically about the building design. It can be energizing for the architect and the builder in that you have to think about the details and the systems, the enclosure, the form is what is driving the performance of the building. And you see that, how the details come together that can make or break the performance of a building. And so you're working at a bunch of different levels, which designers, architects are taught to do, but you really need to do it. And it can be really rewarding to do that. And to work with builders, we see all the time where, an architect may have worked out a detail and it may be theoretically work great, but a builder can come and say, hey, we can get the same performance if we do this, this, and this. It's going to actually be cheaper and easier and more successful ultimately. And so it kind of brings the team together working in a much stronger way, or it can, in the best circumstances.
And Vito, do you find that true on the building side of things when you're working on these? There's more coordination
Yes.
and more.
Yeah, it's true. But you got to make sure all the trades work with the passive house, and they all work together to make sure that the project goes right.
Right. And was that something that was very challenging on the buildings that you worked on?
Yes. Challenging to get them all together.
So I guess, aside from the environmental aspects, right? Because, we speak a lot about that, but what are the other implications of building like this? Because when I look at it, usually I'm talking to clients about air quality, quality of life. It's really not about environment. And I guess someone want to speak to that a little bit as to, what else can we stress that this helps do to projects? Oleg, do you want to go on that?
What I can say about a passive house and generally, it's knowing what I know now and the experience I have, it's really very kind of a low risk proposition, provided you have a very good design team in terms of experience and construction. Then it's really like no-brainer to build a passive house. There is people are aware that what needs to be done in what sequence is important, where they are really kind of driven by the quality of a product. So when they deliver the passive house, it's really high quality building, which is by all the things we actually have a data for, it's actually could last 100 years with no real problems. Because everything we know what is destructive in a building, it's water, a moisture, a rain. And that's when it's actually taken care of by the way you assemble the building, the envelope. You're really eliminating practically all the problems that the old building might have. That's all I have.
Anything? Aside from the environmental benefits, right? We're talking about the occupant, benefits. So have you seen that, as you're nearing completions of the building, how does it affect how the buildings feel, when you go through it with the customers at the end?
I think you got to get the architect, the engineers all on the same page and try to do it right.
Okay. Yeah, I mean, I know that, aside from the noise, the noise aspect is one thing, especially in New York. I think that we had the Hatzala building, like it was built next to the tracks, was built passive so that we don't have the noise from the tracks interfere with the dispatch. And, so it has benefits aside from environmental that I think are very useful and very helpful for people, and that's kind of one of the things we want to try to stress.
Yeah, I mean, I think people, the best way to sell somebody on doing a passive house is to have them go into a passive house and you feel it's not just acoustic quietness, but it's thermal quietness. And time and time again, people will walk into one and they're like, oh yeah, I want this. It's just, it's qualitatively just distinct and different. And to what was mentioned before, the durability of the structure and the long-term, relatively low maintenance, low callbacks, just the higher quality that goes into ensuring that we're getting these performance points is a real bonus that has a lot of value at the end of the day.
And does anyone want to speak to longevity, especially with the electrification bills that are being passed, and what's going to happen to buildings, in the future with no gas, and how that gets affected?
Yeah, I mean, I'll just note, so we see energy codes increasing over time. We see laws like Local Law 95, which is, putting caps on carbon emissions, that if you do a passive house today, you are, in a way, what we would call future-proofing the building, that you're going to be safe in terms of not having to find yourself behind the curve and having to undo something or redo a building just because it wasn't built to a good enough standard. So that's really nice to be able to lock that in.
Yeah, I think that that's something that's important because your loads are going significantly down, which means that you can electrify without really having to worry about it. Oleg, any more?
I actually would like to kind of talk about a multifamily, large family buildings, especially if you own one. Then it's easy for the owner of a building as a passive house. It's really hard. It's very easy in terms of maintenance because there is a very few maintenance calls, and there is very little complaints and more about noise, in the fenestation problem, and the tenants don't really don't have a they don't really leave the apartment because it's uncomfortable, so they stay longer in the apartment. So everything kind of points out for long-term investment in a passive house as a multifamily building, rentable.
And less bugs, or no bugs. Which is one thing that I guess we don't really talk about much, but it's a benefit that I think everyone in the city would agree is useful. Does anyone have any last thoughts? Ken, you want to start that off?
Yeah, I mean, I just think it's going to become normalized over time. It's a matter of how long. We see the codes moving in this direction, and it's something we can do today and kind of skip to the logical endpoint and deliver that predictability. And we see different stakeholders, like schools, that want to have better indoor air quality for their students, so the students stay awake and alert, and they can shelter in place if the power goes out. If there's a wildfire event and there's wildfire smoke, that they could be protected from that. There are all kinds of reasons why schools will see more and more of that. And then in multifamily building, workplaces, offices, for many of the same reasons. So definitely when I discovered it 15 years or so ago, I felt like I was seeing the future, and it is growing, step by step here and there across the country and around the world. There's a lot happening in China. There's a lot happening across Europe, as well as Australia, New Zealand, Canada, and so forth. Latin America is starting to happen. It's just really, when you break it down, it sounds maybe a little bit hard to believe, or a little bit, risky maybe, because it's new. It's a little different in terms of how we're thinking holistically about the building coming together through energy. But once you kind of bury through that, you realize it's a lower risk investment. And the logic holds across a bunch of different ways. So, it's still the early days. It's like we're just getting started.
All right, thanks. Yeah, go ahead, go next.
I actually want to add to this, just to show from my experience how versatile the passive house is. It definitely can do single family, multi-family house. It's actually even apartment in a multi-family house can be done as a passive house. And the people take a full advantage of that in terms of you have a neighbor who is actually smoking, and it's really bothering you. It's actually smoke's coming to your apartment, and there is nothing you can do. There is something you can do using the passive house principle to basically isolate yourself from all the unwanted noise, smoke, and everything else.
All right, thank you. Vito? Anything? Nope.
Passive house is the future. So either you do it now or it's going to get it done later.
All right. Thank you, guys. Yeah, I mean, I think ultimately it's the way that we're heading, and I think that, it's been like that for a while now. And to me, I know that everyone's kind of heard, different green terms thrown around, or, over the years, but at the end of the day, like, this really seems to make sense because it's more about the experience, and it's about providing the client with something that they want, and actually, being able to deliver a premium product and something that you can actually feel and experience, rather than just like some conceptual, green trend.
I just wanted to note that many states are seeing Passive House as, delivering on a whole bunch of priorities that they have as states, whether they're public health issues or environmental issues, and or just energy security issues, as they're looking to increase their, to their power supply. Energy efficiency, this dramatic energy efficiency is really attractive. So that they have incentives for training. So New Jersey Clean Energy Program has a $2,000 incentive per person for training, so you can get your training essentially for free. And states also have incentives for buildings. New York has pretty substantial incentives around building to Passive House standards. In Massachusetts, it's actually become building code in many jurisdictions. So these are other indicators of the markets moving.
Yeah, and it's definitely getting closer to building code in New York also, especially, you see just the insulation levels are getting very close. Continuous and bad insulation in all cavities. Like, it started off 10 years ago, that was something that was kind of like just introduced into the energy code, but it's part of what Passive House, part of those principles. So I think that it's kind of a no-brainer. All right, I guess, thank you everyone for, anybody questions? Yes.
Yeah, so, yeah.
So,
So
you wanna go with
just briefly, yeah, so the insulation, typically it's going to be slightly more insulation, okay? But then it's also, we really would like it to be continuous insulation, right? So you've got, it's not going stud to stud, it's wrapping around the outside of the studs of the building. So we're not allowing those studs to be thermal bridges and reducing the effectiveness of the insulation. And that same thing is happening on the roof as well as under the slab. The windows are typically going to be, in this climate, in this area, to be triple glazed and triple gasketed. They're truly thermally broken frames, and they act as continuations of the air barrier and the insulation, the continuous insulation. So how we install the window and place the window in the wall so that we don't have a thermal bridge around the window. A lot of times, pretty good windows or even very good windows are installed in a relatively poor manner in terms of the detailing of it, and it undermines the performance of the window, so you don't actually get the value of the window. In a Passive House, we want to make sure that the window component's good, the wall's built right, and the connections are robust, and that makes a big difference. So it's not so much the technology or is different, or it's a different way of building, but it's more intentional to make sure, and we're testing it to make sure that we have that air tightness. And so we're trying to eliminate those thermal bridges. We talked about the structure. The same way we're using, we're holding the energy for keeping warm in the winter, we want to prevent unnecessary overheating in the summertime, right? So we want to limit the amount of air conditioning that we want to use year-round. So external shading can often be something that we think about that isn't typically done where we have central air conditioning in buildings. And then the ventilation system. So we have in a home or multifamily building, you have heat recovery ventilation units. that we're bringing in fresh air and we're exhausting the stale air, but we're making sure that it's going through a heat recovery core to maintain the energy within the building. So there's, these are the 5 basic things.
And I think kind of, if this is what you're asking also, it's not inherently much different in many ways, but it's about paying more attention to how those things are actually constructed. So you need air sealing. Part of the energy code right now, you need to air seal your building, right? The question is, are they really doing it, or are they just putting over a sheet and half taping it and half nailing it and calling it a day? And this is about following through and making sure that it was done according to those specifications. So it's not necessarily about different building techniques. It's about being more careful about those building techniques. And then, yeah, you do need an air exchanger. So when you are building a tight envelope, you don't want to be breathing in that stale air. So you need to make sure that you're installing another energy recovery ERV or an HRV to essentially exchange the air within the room so that, you know, it's healthier. But again, you don't really want to be breathing the same stale air anyway, so.
You can
Yes.
retrofit.
You can retrofit.
So it depends on, typically what we see happening is either a property is bought and they're going to do a substantial renovation when the property is changing hands, right? And so you're getting to the bones of the building to make that happen. If you're occupying a building and you're not, and you want to upgrade the building, oftentimes folks are doing step-by-step retrofits. So you make a long-term plan for the building, and basically what it means for it to be fully made into basically passive house performance. The windows, the insulation, the air tightness, the ventilation, and the heating and cooling systems. But you do it as you have access to different components, as things, the useful life of components ends and they need to be replaced. You then take care of it piece by piece. But you make a coherent plan, so again, you know where you're going to land at the end of the day.
And it's fairly common for buildings, especially brownstones in Brooklyn and in Manhattan, to get retrofitted to passive standards.
But
It's done all the
typically
time.
they're going to be like one-time gut renovations.
Yeah.
It's
It's very hard to access.
easier to do a gut renovation. But it's not. So I mean, the passive house principle would just say, because your windows need to be replaced, and you're going to buy new windows, rather than getting mediocre windows because the walls aren't that great. So why am I going to put a great window? Passive house says no. Put in a great window. Install it the right way. Have a high quality result for your effort. It's going to cost a little bit more money, but you're going to get the comfort from that window. And at one point you are going to tackle that wall, and you're going to make the wall better. You need to have the intention and the plan to do that one day. But then you end up with a high quality product at the end of the day, rather than renovating all the different parts of the building, and at the end of this whole cycle of cost and effort, you still have a relatively poor performing building. So you take that opportunity.
Anyone else? No? All right. Thank you guys for joining. And if you have any other questions, you can let us know. We can always reach out to us, and happy to share more.
Thank you, Neil. Thank you, guys.
Thank you.